Okay, YouTube, this is my last video in this module on graphing sine and cosine curves. We're just going to look at one more graph of a sine curve here and kind of look at the variations you'll see. And also in my last video, we kind of forgot to identify domain and range. So we're going to make sure that we do that in this video. So let's go ahead and start with, again, graphing. We want to identify the values of A, B, C, and D within the function here. So go ahead and look above here. Notice that our A value is this 4 right here. Our B value, this coefficient of x, 2 tells us that our graph's going to go through 2 cycles in a normal 2 pi period. We have a c value here. It looks like it's negative, but really we know better. We say it's positive pi halves. And then it lacks completely any d value out here. We could say plus 0. So this is a graph that's not going to be translated vertically at all. Looks like that we have a graph here that's just going to be shifted right and have an amplitude change here. It doesn't look like it would be reflected because it lacks a negative as an a value there. So let's go ahead and start with the 3 things that we want to know for every sine or cosine curve. So those would be the starting point, the amplitude, and the period. So starting with the starting point, recall that the starting point is equal to the point C over B comma D. And so in that case, we have our C value here, which is a positive pi halves over B. Now our B value being 2, we're going to have to split our pi halves in half. And we say our D value here, the nice thing here is that it's just 0. Now with respect to amplitude, amplitude is the absolute value of our A value. And so because we have an absolute value of 4, we have an amplitude of 4. So I'm going to go ahead and put a box around that in a different color. And then lastly, we say the period is always the normal period of the graph. The normal period of a sine or a cosine curve is 2 pi. And we'll divide that by b, which is the number of cycles we'll go through. So if we go through 2 cycles in a normal 2 pi period, then the period now would just be 1 cycle's worth of period at pi units there, pi units of period. So simplifying this pi halves halved, I suppose we could say pi halves split in half, divide by 2. Same as multiply by the reciprocal, so multiply by a half here. We'd say pi fourths is going to be that starting value there. And so the starting point, let's go ahead and write this out here, is at the point positive pi fourths, it's going to be shifted right pi fourths, comma 0. We'll put a box around this. So let's go ahead and construct our graph now. Now considering that our graph is going to be shifted right of 0 pi fourths units, I suppose that it would be fair to say that I don't need to draw like a big left side of my graph here. So I suppose that what we could do is we could just leave a little nub over there and we could say let's extend it to the right. And so we have this graph and it looks like we're starting left pi fourth units and we're going to have a period of just pi units, and so we're not going to go that far past 0. So I suppose we could space this out a little bit here. Let's go ahead and start by calling maybe this point right here. Ooh, sorry, we're going right pi fourths. I suppose I don't need to space it out much at all. So we say that right here is pi fourths. So we're going to have a little bit of room here, but our starting point is at pi fourths comma 0. So we'll put a little box right there. So let's get the height of our frame. Height of our frame being 4 means we're going to go 4 above and 4 below. From a height of 0, it looks like our maximum height is going to be at a height of 4 and our minimum height is going to be at a height of negative 4. So we can space this apart. We get a lot of real estate here. We say, okay, so now adding on the period length to pi fourths, we have to say, well, what would pi fourths plus the period length be if we add on pi? Now that would be pi wholes, which in the same sense would be 4 pi fourths. We could see that our ending x value would be at the x value 5 pi fourths. We're just going to pick an arbitrary value here. I'm going to call this here 5 pi fourths. So from here, let's go ahead and construct our frame. We're going to go up 4 units and down 4 units. And we're going to go outward just pi units to the right there, which would land us at 5 pi fourths. So we have our frame. So splitting this in half down its midline. Now we're going to split this in half. So this would be the x value that is the midpoint of pi fourths and 5 pi fourths. Because these are both in pi fourths, what I'm really going to do is I'm just going to say what's 1 plus 5 divided by 2, because really 6 divided by 2, that would be 3 here. That's going to tell me the number of pi fourths. We'd say that this is really 3 pi fourths right here, and then we're going to split these in half. And you can see that splitting those in half, the midpoint of 1 pi fourth and 3 pi fourths is 2 pi fourths. I'm going to put that up here. I just don't want to get a little too crowded here. And this would be 4 pi fourths. And you could see that this simplifies out to be just a pi half. And this would be just a pi, okay? But you do need to write those out. So we say, with respect to our frame, we are graphing a sine curve here. And because we have a positive a value, positive we know that we don't have a reflected curve. So with our sine curve usually starting at 0 and going up to its maximum, we'll just go ahead and fit this into our frame here. And we say that here is our sine curve. And just very poor at drawing on this thing sometimes. You have to understand, though, that this graph kind of goes on forever and ever and ever and ever. So the one thing that I did forget to do in the last video, shame on me, is to indicate the domain and range. So the good news with sine and cosine is just simply this. Every angle, I mean, this graph goes on forever and ever. The f means that every angle that we plug in for x, you always have a sine or cosine curve. And when you think about the unit circle, we also see that any angle there is always going to have a point on the outside or the exterior of the unit circle at that angle. So there's always an x and a y. There's always a cosine and a sine. So our domain is left and right forever and ever is negative infinity to infinity. Now with respect to range, we see that on the y-axis here, I'm going to kind of try and draw on here, on top here, right there. Between positive 4 and negative 4 here is this interval of y values for which our graph has sine outputs, okay? And so we would say from negative 4 to positive 4, this is our range of this graph right here. Cheers.